uh, I have shared my laptop screen. I think the PowerPoint presentation is visible from your side. Is it? Na?
No, sir. No, sir.
No, sir.
Not visible.
Sir, actually, it is just a rainbow.
Actually, it is. Okay.
Sir, it's just a band of colors, sir.
A band of colors. Okay. Stop presenting. Now, what you can see,
Yes, sir.
PPT.
It is visible.
Okay. Now it's fine, na?
Yes, sir.
Okay. Thank you. Whatever actually, if, we can end in our last class, the data model. Basically, the data model, the structure of the database is the concept of data models. The data models is basically one of the conceptual tools, like the conceptual tools for describing the data relationships, data semantics, different data consistency constraints. Okay, data model that provide the basically the way of describing the to designing a database at the physical uh, uh, the design of the database at the physical level, logical level, or conceptual level, and as well as the view level. Okay, there are different data models are there. Of course, the all the data models are actually not describe the physical, logical, and as well as the view levels. The the, the all the data models are actually, I mean, uh, classified into uh, four categories. That is the record-based logical model, object-based logical model. For example, entity relationship model, object-oriented model, and maybe the binary model, semantic data model. That is the binary model or semantic data model, and so on. There are some other object-based logical models are also there. Semi-structured data model is there, that is in between them, and physical data model that can describe the physical level schema. So the first one is the record-based logical model. Here, in record-based logical model, their relational model is there, network data model is there, and hierarchical data model is there. That means this can be again categorized into three categories. The mostly industry in earlier days and as well as the at present also use the uh, relational data model. That is this data model is the most popularly used at past and present also. The network data model and hierarchical data model, earlier it is used, but nowadays actually very few old databases are there that can be used by the very few enterprise. And our syllabus actually also based on this relational data model. So the first thing is actually the record based logical data model. So this one actually, this type of data models that is under this actually relational data model, network data model, hierarchical data model actually falls. This actually used to describe the conceptual level and as well as the view level. Okay, and this model are used both to specify the overall logical structure of the database and provide a higher level of description. I mean, higher level of description of the implementation. And why the it called the record based logical model? That is why the name is record based. Basically, this such model uh, used to describe the database is structure in fixed format record. That is, database actually expressed as a fixed format records, several records, and I mean each records defines the fixed number of fields. Each records, that is, it is a fixed format record of several types, and each record actually defines the fixed number of fields or called the attributes or columns, and each field is usually a fixed length or maybe the variable length, but fixed length or variable length. Okay, that is what actually I called that. It is known as the record based model because the database is stored in fixed format records of several types, and each record is defined, or each record type defined as a fixed number of attributes or fields, and each field is usually either fixed length or variable length. In reality, or in actually, the use of the fixed length record that simplifies the physical level implementation of the database. For that, most of the cases, the fixed length fields are used. What is the benefit? The benefit is actually it simplifies the physical level implementation in the database. But richer structure of the database must use variable length record at the physical level. And this record-based logical data model, that is the record-based data model, does not include any mechanism for direct representation of the code. That is, to represent the code, it is not inbuilt with the database. Instead of that, there is a separate, there is a separate language that are associated with the model to express the database query and updates. Is it clear? That is, record-based logical data model does not include the mechanism for direct representation of the code. That is, the direct representation of the code is not inbuilt with this data model. Instead of that, there is a separate language which is associated with the model to express the database query, to access the database, to update the database, and as well as to create the database, of course, modify the database also. But if we compare with the object-based logical model, there some of the object-based logical model consist or includes the executable code as an integral part of the data model itself. That is, there some of the object-based logical model is present there. The code, to represent the code, is already inbuilt. But in case of relational not a relational, means in general record-based data model, there is a code representation is not directly inbuilt with the data model. Instead of that, there is a separate uh, language is associated with this with the particular model. And I already told the widely accepted data models which are based on the record-based logical data model are the relational data model, network model, and hierarchical model. So, what is the relational? Relational data model. And I already told that these relational data models are actually mostly or widely used data model in past and as well as the at present. The majority of the current database systems used by the different enterprise or organization is based on the relational model. And how actually relational data model actually represent? The relational data model is represent data and also the relationships among the data by using a tables. That is, here in this model, the data and as well as the relationships among the data is represented by a table. That means it is a set of it is a collection of this model actually is a collection of tables basically. So the tables are also here sometimes we can call the relational, and each table has multiple fields or attributes to define the table or to describe the table. And of course, each of the fields are actually with a unique name. For example, suppose the customer table or customer relation. This table relations are synonymous. Okay, though the term actually in relational model use the table and as well as the relation. For example, the customer table or customer relation, and there the customer relations are described by a multiple attribute. What are the attributes? Say customer name, customer city, customer phone number, and so on. If we consider suppose the banking database, then there suppose the customer table consists of what are the fields or attributes are there. Customer ID is there, customer name is there, customer street, customer city, and account number. And as well as there are some other fields are also there for the limitation of the space. We have not considered that one. Maybe the phone number or some pin code number, and so on. Is it clear? Am I audible, please?
Yes, sir. Sir, could you go to the previous slide once, sir?
Need to go to the previous slide.
Yes, sir. Could you just go, sir? I missed one part, sir. That's right.
This slide?
Thank you. Yes, sir. Yes, thank you, sir. Thank you.
Any question?
No, sir. I just needed to see the widely accepted data models, sir.
The widely accepted data models is the record-based data models are. There are some other data models are there that actually fall under the record-based logical data model. These three are popular, but at present, relational data models are most popular and most widely used at present and as well as the past. In past, network data model and hierarchical model are also popular, but in present scenario, they are preceded from the relational model, which means at present very few organizations use this network and hierarchical model. Okay. So the relational data model is the record-based logical data model. Here, what I told, relational model use a collection of tables to represent the data and as well as the relationship among the data. That is, and each of the table is also known as the relation, and each of the table is described by the number of attributes or number of columns with a unique name. Okay, this is a, for example, the customer table, this one. Say account table is the another table. Say account table consists of the account number and balance. Say another table, say account table. The account table actually consists, suppose the this this account number, you can write in a short account number and balance. Okay, this is the account table. Okay, so this one actually this account table actually described by the true attributes account number and balance. Okay, so this relational model, why we called it is a record based data model, or why it is fall under the record based logical data model, because the database is structured here. A fixed format records of several types. What is the type? In previous example, this records, that is, this is one of the record. Okay, you already know, but I can just, this is one of the record. What is the type of this record? It is a customer type of record. Say this is the another record. This record, what type of? Customer type of record. Similarly here, number of records are there. Each of the records are actually here what type? These records are what type? Account type of record. Okay, so, and these records are actually, fixed format record of several types. Why several type? In example, I can told you that here, for example, customer type, account type, and so many other types are also there. For example, the loan type, depositor type, borrower type, okay, asset type, and so on. And each table contains a records of a particular type, and each record type defines a fixed number of fields or attributes. That is, in customer table, you can see in customer table here it is described by the fixed number of, that is the 5 number of attributes: customer ID, this customer ID, customer name, and this customer street and customer city and account number. Similarly, the record account actually defined by the 2 number of attributes: account number and balance. Okay, whatever actually I already told, the network model actually use at present very few enterprise or organization. Network data model. In the network data model, are represented by a collection of records, because network data model and as well as the hierarchical data model, I already told, relational data model, network data model, hierarchical data model, these 3 models falls under the category of record based logical data model. So here data is represented by a collection of record, but relationships among the data are represented by a link. Okay, represented by a link. Whereas in case of relational model, the relationships among the data also represented by a table. But here actually the relationships among the records or among the data represented by a link, and which can be just like a view as a pointer like or something. I can consider the example just. That is, oh sorry, data in this model are represented by collection of records, and here relationships among the records or among the data, the relation among the data are represented by links. Okay, by a links or pointer, links or pointers. That is, for example, suppose say this is the customer record. Here customer ID is there. Say customer ID is the C111. Say customer name is the say Osit. Here customer, what I consider here, customer name, customer street, and I mean customer city and account number. Say customer city is the North City. Say street is the Howrah, and here say account number is there. Okay, is it clear now? This is the customer record, just similar to the previous one. The customer ID, this is the customer ID, this is the customer name, this is the customer street, customer city, account number. Okay, so similarly here other customer records are there. Say this is one is the say Sumit. Say other, so many customers records are there, and not only customer records, some other records are also there. Okay, suppose these are the records to represent the, that is the account records. It consists of account number, and this is the balance. Okay, that is say account number is the say here 9125, say 9125, and balance is say 95000. Okay, similarly other account records are there. Is it clear now? That is a account records. And these are the customer records. That is, these are the customer records. Okay, these are the account records, these are the customer records. Now how actually relationships actually exist? Relationships exist by the link, just like this one. Just a minute. So this is the 2398, and balance is say 150000, and so many. So what actually this one? This is the say account number say 1129. Say balance is 10,000. Okay. Now what actually described by this network data model? What actually I already told. the network data model is represented by a collection of records, several type of records, and relationships among this record or among this data is represented by a link or pointer, like this one, this one, this one, so on. So how actually relationships maintain, or what is the meaning of that? By this actually it is clear the customer Osit have account in the bank. What is the account number? This is the account number 9125. And how much balance actually present at present? 95,000. Okay. Similarly, customer Sumit have account number 1129. 1129. Okay. But you can see here the account number 2398 is shared by two customers, Osit and Sumit. This is a joint account. Maybe they are actually business partner, or maybe the family members. That is, this account number 2398, where 1,50,000 rupees is there at present balance. This account jointly shared by customer Osit and Sumit. That is, this network model is here. Records are actually organized as a collection of arbitrary graph. Is it not? This is a collection of arbitrary graph. That is, here records are organized as a collection of arbitrary graph. Okay. Is there any confusion to get the basic idea?
Yes, sir.
Confusion or not confusion?
No confusion, sir.
I think how relational data model express the database and how network data model express the database, I think basic idea is clear. Now,
sir, one question, sir. Sir, what did
please.
you write in green, sir, at the top, sir? Your record.
Here, write the, in case of network data model, that is, in this network data model, records are organized as a collection of arbitrary graph. You can see that this figure, this figure is an arbitrary graph. The records are connected by a link. It is an arbitrary graph. So that things actually I can write the network data model. Their records are organized as a collection of arbitrary graph. Okay. And the next hierarchical data model. The hierarchical data model is same as the network data model. The hierarchical data model is similar to the network data model. In that sense, here data are represented by a collection of records, and among the data is represented by a link, similar to the network data model, but mainly differs with respect to the network data model. In case of hierarchical data model, records are organized as a collection of tree. That is, this is similar to the network data model, but here means hierarchical data model. Here records are organized as collection of tree. That is, this is a tree-like structure, collection of trees, rather than arbitrary graphs. Okay. That is here. You can think like this one. Say this is Osid. Just a minute. Say this is Sumit in our earlier example. Say another customer. For example, sorry. The Osid have the account number 9125 95,000. 912125. Oh, sorry. 9125 95,000. Okay. This is linked to this. Similarly, 2398. 398. Okay, this is okay. Just here, actually, give the brief idea. That is the account number 9125, where balance is 95,000, is the account of customer Osid. This account number 2398, it is a joint account by Osid and Sumit. Okay, and here another account is there, that is a single account of the Sumit, and so on. So what actually you can see, this is a tree-like structure. Okay, instead of any arbitrary graph. I think the basic idea of relational data model, network data model, and hierarchical data model, and their little bit difference is clear. Whatever I already told, the relational data models, how actually differ? The relational data models, they are data and relationships both represented by a tables. But in case of network data model and hierarchical data model, the data represented by a records, but relationships among the data represented by a link. But in case of relational model, relationships among the data is represented by a table. Or table, or more specifically, we can say by a record. Okay. Now, next one is the object-based logical data model. In object-based logical data model, they are actually use these data models are used to describe the conceptual level and as well as the view level, not the physical level, similar to the record-based logical data model. Okay. And here so many models are there, though we can discuss in our syllabus mainly the entity relationships models are there, and these models are very popular to design the databases in the conceptual level and as well as in the view level. So in ER data model or ER model is based on the perception of the real world, which consists of a collection of the basic objects, and that basic objects are actually called here the entity. Okay, basic objects are called entities, and the relationships among these objects. You already have idea in fourth semester the object oriented programming is there, the concept of object oriented. That is this year entity relationship models are concept of object oriented concept. That is here the basic objects are called entities, and relationship among these objects whatever actually I want to told, that is here entity is an object in the real world that is distinguishable by the other object with a specific set of attributes. That is similar to the relational model and network data model, and also their records are distinguished by the number of attributes. Here also the entity or objects in the real world are distinguished from each other by a specific set of attributes. And relationships is an association among the several entities. For example, you may consider, for example, whatever actually I consider in my previous example in the banking database system, the customer is the one of the entity, is it not? If we consider think like in the real world, a customer is the one of the object or one of the entity. This customer actually represented by a, or how actually one customer differ with the other customer? How actually differ? By name, is it not? By name, by the, suppose the, if we consider in reality by Aadhaar number, by PAN number, is it not? So these customer objects differ with each other by a set of attributes. Say attributes we can consider, say suppose customer ID, customer name, customer address, and so on. Similarly, the another object is the account. This account object, how actually distinguish the two account object or number of account object? By the attribute. Attribute is the features basically. That is, in case of account number, and we can consider the balance. Is it now? So account object or account entity, this is the customer entity, and this is the account entity. Account entity is represented by account number, and this is represented by balance. These are the two attributes. Similarly, here number of other attributes are there. Okay, up to that is clear, na? That is here entity relationship model. Objects are the entities, that is customer entity, account entity, and how actually relate? Relationship is the association among several entities. That is here, not this customer entity, not only a single number of customers are there. So at that time it is called the entity set, not the entity. At that time it is called the entity set. And in account, number of accounts are there. Single account is called the entity account, and set of all the accounts, that is set of the same type of entity, is called the entity set. So this is the account is the, this one is the entity set. So this customer entity set and account entity set, that actually some relationships are there. So here say relationship depositor. Say we can say the relationship is the depositor. This actually depositor, this relationship, this one actually relate the customer with the customer entity or customer object with the object of account. Who actually relate is depositor. So similarly, to identify the depositor, there maybe some attributes are there. Maybe some specific attributes, some attribute actually taken from the customer entity, and some attribute taken from the account entity to maintain the relationship in between customer entity set and account entity set. And maybe some more attribute is present in the depositor relationship set. This is the depositor relationship. This is a relationship. This is a relationship. Okay. Here this is the entity set. Okay. So the details of the relationship sets and their attributes and how different type of association actually present, we can discuss when you talk about the details of the details of the ER data model. But before that, actually, this entity relationship model, and also another important point, entities and relationships in ER data model represent a certain constant to which the content of the database must conform or must satisfy. And one important constant is the mapping cardinality. The details of the mapping cardinality we can discuss when we talk about the details of this chapter. And this entity relationship model is expressed or is represented graphically by an ER diagram. That is by an ER diagram. Okay. This entity relationship model or called the ER model. That is called ER model. Expressed graphically by ER diagram. Here rectangle actually represent the entity set. It represent the entity set. This, okay, just a minute. This ellipse represent the attribute or field that distinguish the, that differentiate the same type of entity from the entity set. Diamond represent the relationship set. Okay. This is a connector line. That is connector line means this line actually that can link in between the entity set with the attribute, or entity set with the relationship set with the entity set, so on. For example, whatever actually I consider as the example, the customer is the entity set. So customer entity set, it consists the customer type of entities, number of entities. This is the entity set, and here it is distinguished by the attribute customer ID, customer name, customer street, customer city. Another entity, say account number and balance. Okay, account number and balance. Okay, so this is also an entity set. For that, it is a rectangular. You can see here, I told the rectangular box actually used to represent the entity set. Now these two entity sets, that is the, this consists the data about the customer, and this consists the or reflect the data about the accounts. This data actually how relate? By a relationship called here depositor. Okay, this depositor is the relationship set. That is, this is a entity set. This is a relationship set. This is also a entity set. So by this relationship set, there is a, I already told, in the relationship set also express the some constant. That constant need to be satisfied. one of the such constant is the that constant need to be satisfied by the content of the database. So one of the important constant is the mapping cardinality. There one-to-one mapping, one to many, many to one, or many to many mapping is there. In this case, this is a, for example, suppose if we consider customer have a
Sir,
account in the yeah.
sir, we have a
Yeah.
class now, sir.
Okay, okay, sorry. Okay, just a
Sir,
minute.
one question though, sir. What is the ellipse for, sir? The ellipsis stands for?
Ellipse stands for attribute.
Okay, sir.
These are the
Okay, sir.
attribute, or you can call the field. Okay, that represent the characteristics, one of the characteristics of the customer entity.
Okay, sir.
Is it? So okay, the data definition language or data manipulation language and some other rest portion we can discuss in our next class. So still you have any question? The other students, do you have any question, please?
No, sir.
No, sir.
Okay, just a minute.